In 1950, a machine shop in Racine, Wisconsin, built its first milling machine. It weighed close to 3,000 pounds, which was roughly 1,000 pounds more than the machine everybody else in America was buying. And for the next 50 years, the toolmakers who ran one all said some version of the same sentence. It cut deeper, it held size, and it did not chatter. Tree Machine Tool would sell those machines into aerospace shops, defense contractors, and half the tool rooms in the industrial Midwest. That was 1950. By April of 2009, the entire company, every print, every part number, every remaining crate of spares, was sold off in a single transaction. This is Trade Archive, where we take apart the companies that built the physical world and the people who stood at the machines. If this is the kind of story you want more of, like the video and subscribe. It matters more than you would think. Racine, Wisconsin, 1926. If you wanted to understand American manufacturing in that decade, you could have stood on a street corner in Racine and simply watched the trucks. This was a city of about 60,000 people on the western shore of Lake Michigan, wired into the national rail network, and it was building an absurd share of the country's hard goods. J.I. Case was turning out tractors and threshing machines. Modine was building heat exchangers. Twin Disc was making industrial clutches. Jacobsen, founded a few years earlier by a Danish immigrant named Knud Jacobsen, was building lawnmowers and light tractors. S.C. Johnson was making wax. 30 minutes south in Kenosha, Nash Motors was stamping out automobiles. All of those plants had the same problem, and it was a problem the public never sees. A factory does not make a tractor. A factory makes the tools that make the tractor. Before a single fender gets stamped, somebody has to cut the die that stamps it. Before a transmission case gets machined, somebody has to build the fixture that holds it, the jig that guides the drill, the gauge that checks the finished part. That work is done in a tool and die shop, and it is done to tolerances that the production floor never has to think about, because if the toolmaker holds 1/10 of a thousandth of an inch, the production floor gets to hold 5/1000ths, and nobody notices. Tool and die is the trade that stands behind every other trade. It is small, it is precise, it is unglamorous, and in 1926, in a city like Racine, it was where a man with hands and patience could build something of his own. That year, Charles Tree opened Tree Tool and Die Works. For the first 2 decades, the shop did what tool and die shops do: contract work, dies, fixtures, special tooling, jobs that came in from the big plants across town and went back out again as steel. There is no dramatic origin story here that anyone wrote down. What survives instead is the paper trail of a man who could not leave a machine alone. Because Charles Tree was not just running a shop, he was patenting. The earliest patent that carries his name and his city is from 1941, a Call-It Index feature, U.S. Patent 2,233,858. That is a small thing. A collet is the sleeve that grips a cutting tool in a spindle, and indexing it means being able to rotate it to a known position and lock it there. The kind of improvement you only think to make if you have been fighting the same annoyance for 10,000 hours. Then, in May of 1947, he filed the one that mattered. U.S. Patent 2,517,738. Taper boring head. It issued on the 8th of August, 1950. Understand what boring a taper meant before this existed. A tapered hole is a hole that changes diameter as it goes deeper, and it is everywhere in mechanical engineering. It is how a Morse taper tool holder locks into a spindle. It is how a Brown and Sharp taper seats. It is the profile of an engine valve seat and the throat of a carburetor venturi. Cutting one accurately required either a dedicated machine, a specialized attachment most small shops could not justify, or a level of setup gymnastics that ate an afternoon. What Tree designed was a boring head that could do it on an ordinary mill. The patent describes an internal gear train, planetary gearing working with a worm gear and a rack and pinion, driving an automatic feed on the tool slide as the head rotated. The tool did not just spin. It walked outward or inward at a controlled rate while it spun, at a feed the patent puts at 5/1000ths of an inch per revolution. Set the slide at 0 degrees and you bored a straight hole. Set it at 90 and you faced. Set it anywhere between and you cut a taper, at whatever angle you dialed in, on a machine that already sat on your floor. He was selling capability to shops that could not afford capability. That was the whole business model, and it worked. 2 years later, he had a second one. U.S. patent 2,491,940, issued in December of 1949. The universal milling head. Most small shops in the 1940s owned a horizontal mill because horizontal mills came first, and they were what was available used. A horizontal mill cuts with the spindle lying on its side. A vertical mill cuts with the spindle pointing down, which is far more intuitive and far more useful for die work. If you owned the wrong one, you were stuck. Tree's attachment socketed directly into the hole where the round overarm of a horizontal mill normally sat, and it turned that machine into a vertical mill. Competitors had tried this. What separated the tree head was that it did 2 motions instead of 1. It swiveled, and it also nodded, tilting up and down on a second axis. A head that only swivels gives you angles in one plane. A head that swivels and nods gives you compound angles, which is exactly what die work demands, and exactly what nobody wanted to set up on a rotary table at 4 in the afternoon. Those 2 attachments did something for the company that no amount of contract work could have done. They generated capital, and more importantly, they generated a reputation with the exact customers who would later buy a whole machine. Which is what happened next. In 1950, Tree Tool and Die Works built and sold its first complete milling machine. The company's own account of that moment is short and, for once, not marketing exaggeration. It describes the machine as exceptionally rigid and accurate, with features toolmakers wanted and could not find anywhere else. The model that came out of that program and defined the next decade was the Model 2 UV, a universal vertical milling machine, and when the trade press of the era introduced it to the metalworking world, the feature they led with was the column, a 45-degree dovetail column with extended knee construction. That sounds like nothing. It is the entire argument. Here is the competitive landscape Tree was walking into. In 1938, Bridgeport Machines in Connecticut had introduced a vertical knee mill built around a ram and turret arrangement, and by 1950 it was on its way to becoming the most copied machine tool in history. A Bridgeport Series 1 weighs roughly 2,000 pounds. It is light enough to move with a decent forklift, cheap enough for a startup shop, and flexible enough that the head can be twisted into nearly any position you can imagine. Every small shop in America either owned one or wanted one. Tree looked at that machine and made the opposite bet. Instead of a ram and turret, a heavy dovetailed column at 45 degrees. Instead of 2,000 pounds, closer to 3,000. Instead of maximum flexibility, maximum stiffness. The pitch to a toolmaker was not that the tree could get into more positions. It was that when you took a heavy cut in tool steel, the tree did not flinch. That distinction is the difference between a machine you like and a machine you trust. Every cutting tool is fighting the machine that holds it. When an end mill bites into hardened steel, it pushes back, and everything in the load path deflects. The spindle deflects. The head deflects. The knee deflects. If the machine deflects and then springs back, you get chatter, that scream and washboard finish every machinist recognizes, and chatter is not just ugly. It ruins finish, it destroys cutters, and it costs you size. The response is to take lighter cuts, which means more passes, which means more hours, which means the job costs more. Mass fixes it. Not because heavy is magic, but because a heavier, stiffer structure deflects less under the same load and damps the vibration that does occur. Machinists who ran both machines put it plainly. One of them, comparing his tree to the Bridgeport he sold, said the tree was twice the machine, and pointed at the reason, which was the amount of surface area on the saddle. The bearing surfaces were bigger, the load spread out, the machine stayed where you put it. That is what Tree sold for the next 30 years, not features. Stiffness. So how do you actually build a machine like that? You start with iron. Gray cast iron poured into sand molds, in shapes that look almost architectural before anyone touches them. The column, the knee, the saddle, the table, the head. Gray iron is the material of choice for machine tool structures for a reason that has nothing to do with strength. The graphite flakes distributed through the iron absorb vibration. A steel weldment of the same stiffness rings like a bell. A gray iron casting swallows the energy and goes quiet. Then the castings come to the shop floor, and this is the part that separates a machine tool builder from a fabricator. Tree mills run on boxways, not the more common dovetail-only arrangements. A boxway is a rectangular sliding surface, and it carries load in multiple directions instead of pinching in one. It is more expensive to produce, harder to fit, and enormously more rigid. Those surfaces are machined close, and then they are finished by hand, by a scraper, by a person. Hand scraping is a 19th century process that no one has managed to replace. A machinist coats a reference surface, a flat granite or cast iron plate, with a thin blue dye. He sets the workpiece down on it, slides it, lifts it. The high spots come up blue. Then he takes a scraper, and he removes those high spots, a fraction of a thousandth at a time, in small, deliberate strokes. Then he blues it again, and again, and again, until the blue is spread evenly across the entire surface in a controlled pattern of contact points. That pattern is not decoration. Those points carry the load, and the valleys between them hold oil, so the way is riding on a hydrodynamic film instead of grinding metal against metal. A properly scraped way outlasts a ground way by decades. Tree machines were also fitted with one-shot lubrication, Bridgeport systems that push oil through metering units to every sliding surface when the operator pulls a pump handle. Pull it in the morning, and the machine is oiled everywhere at once. None of this is fast. All of it depends on somebody having spent years learning to read blue. That is the actual product, not the paint, not the nameplate. Some number of skilled hours, distributed through iron, in a plant on Junction Avenue in Racine. By the late 1950s and into the 1960s, the line had branched into a family, and the model letters tell you exactly what you were buying. A 2UV was the base machine, step pulley head, power feed, and rapid traverse in X. A 2UVR swapped in a variable speed head, so the operator could dial spindle speed anywhere in the range instead of stopping to move a belt. A 2UVRC was the heavy-duty version, variable speed head, power feed, and rapid in both X and Y, with power rapid on the knee available. And the 2VGC took that same pedestal and table arrangement and put a Super Duty head on top of it. A typical 2UVR gives you a table 10.5 inches by 42, about 25 inches of X travel, 11 in Y, 17.5 of knee travel, 4 inches of quill. Spindle speeds infinitely variable from 60 to 3,300 RPM off a 1.5 horsepower motor. The head swivels 90 degrees, cants 45, tilts 90. 2,750 pounds on the floor. And then there is the collet system, which people either loved or fought about. A Bridgeport uses an R8 collet, and to change a tool you climb up, loosen a drawbar at the top of the head with a wrench, tap it, catch the tool. It works. Everyone has done it 10,000 times. Tree used its own double taper collets, size Z, and the operator changed tools at the nose of the spindle with a spanner wrench, standing flat on the floor, at chest height. Faster, easier on the shoulders, and considerably easier if you were not 6'2". The trade-off was capacity. For toolroom work, that covers most of what you touch. For everything else, it was a limit you lived with. And because the collets were proprietary, they were a thing you had to source, which is a sentence that becomes important later in this story. While Charles Tree was designing collet systems, a man named Chedo Filipovich was leaving Yugoslavia. He had been born in January of 1934 in Knez Selo, a village outside the city of Niš in Serbia, and raised and educated in Belgrade. In 1954, at 20 years old, he left the country illegally. He crossed into Austria, and he spent time in a refugee camp at Enns while he worked in the town of Steyr, waiting for a sponsor. The sponsor came. The destination was Racine, Wisconsin. Think about what that city looked like to a 20-year-old who had just walked away from a communist state with nothing. Racine in the middle 1950s was a place where a man with steady hands and a willingness to learn could walk into a shop, get hired, and be paid every Friday for the rest of his working life. That is not nostalgia. That was the actual arrangement. Filipovich founded a tree machine tool company, and he stayed for 30 years. He worked as a machinist. He was, by the account left behind after his death, highly valued, and he trained many newcomers in machine work, which is the detail worth sitting with. Because the thing a company like Tree actually owns is not the building. It is a population of people who know how to read blue, how to feel a scraper bite, how to hear the difference between a cut that is working and a cut that is about to go wrong. That knowledge does not live in a document. It lives in a man standing next to another man at a machine, saying, "No," like this. Filipovich met a woman named Rosalie in 1963 and married her in May of 1964, which is the same year the company changed hands. That year, Charles Tree's son, James A. Tree, became president. James had worked at the family business since he was young. Under him, the name changed from Tree Tool and Die Works to Tree Machine Tool Company, and that was not cosmetic. A tool and die works takes in other people's problems. A machine tool company builds and sells its own product line, which is what Tree now was. And the timing could not have been better, because the customers were about to get very serious. The 1960s tool room was a Cold War tool room. Aerospace contractors, defense subcontractors, and the enormous shadow industry that fed them all needed precision, and they needed it in materials that were getting harder to cut every year. A shop chasing tolerances on airframe fittings does not buy the cheapest mill. It buys the one that holds size at the end of a long shift. And consider what buying one of these meant on the other end. A vertical mill was not a purchase. It was a mortgage. A small shop owner putting a tree on his floor was committing a meaningful share of everything he had against the bet that the machine would still be earning in 20 years, that parts would be available, that the company would answer the phone. That is why reputation in this trade compounds so slowly and collapses so completely. You are not selling a product. You are selling the next 2 decades. Tree leaned on that. The company's own literature would eventually claim 17 patents behind the machines, and whether the count was strictly the founders or the family's work collectively, the point being made to a buyer was the same. This is not assembled. This is engineered. Charles Tree kept inventing straight through it. A ram saddle wedge lock in 1954. A removable feed nut for the crossfeed in 1955. A tool holder in October of 1957. And in 1962, U.S. Patent 3,022,608, a taper grinding tool, a removable grinding head that mounted to a milling machine and let a shop do internal precision grinding on dies without buying a separate jig grinder. Same instinct as the boring head, 15 years later. Sell the small shop a capability it could not otherwise afford. By 1977, the thing that would change everything was already in the building, and it did not look like iron. Numerical control had existed since the 1950s, driving machines from punched tape. It was expensive, it was fragile, and programming it meant writing coordinate code by hand, which meant a shop needed a person who could think in raw G code. In a 15-man job shop in Wisconsin, that person did not exist. Tree went after that problem, and the trail of who was involved is documented in an unexpected place. A control company that would later become Miltronics Records, that among its founders was Tim Raschlager, the former national sales manager of Tree Machine Tool, and that in 1977, Tree was that firm's largest control customer. In 1978, the result shipped. The Journeyman 200, a 2-axis CNC knee mill. The way the company described it afterward was that the machine changed how small shops looked at CNC because it programmed itself from easily entered part descriptions. Strip the marketing, and what it means is that instead of writing coordinate code, the machinist pressed a key labeled Event Type and answered questions. Position, linear mill, circle mill, bolt circle, frame. The control asked for the dimensions in the language the man already used, and it generated the motion. Tree paired the journeyman line with Dynapath controls, from Autocon, the lineage that ran back through Bendix, and the Delta series became the standard fitment. A man who had run manual mills for 20 years could walk up to that control and be cutting parts by the end of the week. He did not need to become a programmer. He needed to stay a machinist. That was the whole insight, and for about 15 years, it made Tree one of the most respected CNC knee mill names in the world. There is one more thing that happened in 1978. In the same year the Journeyman 200 shipped, Tree was sold to Ellison Machinery Company, a machine tool distributor headquartered in Los Angeles, itself a subsidiary of a holding company called Sierra Concepts. 52 years after Charles Tree opened a die shop in Racine, the company stopped belonging to Racine. Nobody on the floor would have felt it that week. The machines still shipped. The nameplate still said Wisconsin. But the decisions had moved 2,000 miles west, and the people making them were distributors, whose business is moving product, not pouring iron. Through the 1980s, the Journeyman line became a range, and the two machines at the top of it are the ones people still hunt for. The Journeyman 325 is the mid-size classic. 10-inch by 44-inch table, 27 inches of X travel, 14 in Y, 6 in Z, a Cat 40 spindle turning up to 6,000 RPM off 5 horsepower, riding on boxways, weighing about 4,600 pounds. The Journeyman 425, sometimes called the Master, is the flagship. 12 by 51 table, 30 inches of X, 15 of Y, 7.5 horsepower, an 800-pound table load capacity, rapid traverse at 350 inches per minute, and a repeatability figure of 150 millionths of an inch. 6,000 pounds on the floor. Read those numbers next to the manual 2 UVR from 30 years earlier, and you can see the company's argument surviving intact. More travel, a computer on the side, the same doctrine underneath. Make it heavy, make it stiff. Let the operator take the cut he actually wants to take. That was the peak. It did not hold. The first hard evidence that something had broken shows up not in a press release, but in a federal filing. On the 4th of February 1983, a petition was filed with the United States Department of Labor on behalf of the workers of Tree Machine Tool Company in Racine, Wisconsin. It is case number TAW14391. On the 14th of October that year, the department certified it. Trade Adjustment Assistance is a narrow program. To qualify, the government has to find that workers lost their jobs because of increased imports. It is not general unemployment relief. It is a determination on the record about cause. And the impact date the department attached to the Tree case, the point from which workers were covered, was the 1st of April, 1982. Which means that by the spring of 1982, the machines coming in from overseas were cheaper than the machines coming out of Junction Avenue, and enough men had already lost their jobs that somebody filed the paperwork. Washington eventually responded to the wider problem with trade restraints in 1986. It came years after the certification, and it did not put anyone in Racine back on the floor. There are men who spent 30 years learning to scrape away flat to within a few tenths, and the paperwork that ended their careers is 4 lines in a federal database. The company's answer was to stop building. By the middle 1990s, Tree had turned itself inside out. Its people shopped the world to find who could produce milling machines and vertical machining centers at the quality and price the company needed. And the work went to 3 builders in the Czech Republic, ZPS, TOS Olomouc, and TOS Kurim. A Journeyman 425 built in that period still carries a nameplate that reads Tree Machine Tool Company, Racine, Wisconsin. It was assembled in Central Europe. What was left in Racine was a $24 million import business and roughly 52 employees, most of them skilled tradespeople, running a parts warehouse. 52 people, in a building that had been pouring hours into iron since 1926. James A. Tree died in Racine on the 11th of November 1997 at 79 years old. He had continued working as an inventor and consultant until 1995, which is the detail that tells you what kind of man he was. He was not a chairman collecting a title. He was still solving problems 2 years before he died. Then came the last owner. The assets passed to the Excel Group, based in Singapore, operating in the United States as American Excel. A machinist who ordered a new tree vertical machining center in early 2001 later described what he found. He had bought what he believed was American iron. When he called, he learned the machine would ship from Los Angeles and that it had been built by Cao Ming in Taiwan. His summary of what had happened to the company was 4 words long. Excel gutted Tree. They stopped building machines, sold the equipment, let the people go, and closed it down, and that process ran through 1999 and 2000. The company was not in Racine by then. It was operating out of Franklin, Wisconsin. And this is the part of the story that almost nobody outside the trade knows. In 2001, as the machinery was being auctioned and the doors were closing, a group of former Tree employees in Wisconsin did something about it. They bought the machine shop. They bought the special machines, the fixtures, the parts, the equipment. Critically, they bought the prints. Then they set up in Oak Creek, 20 minutes north on the lake, under the name 3S Incorporated, and went into the business of keeping tree mills alive. They could rebuild a spindle. They could make a part that had not been manufactured in 30 years, from the original engineering drawings, because they had the drawings and they had personally built the machine the part went into. The corporation died. The knowledge walked out the door and set up shop down the road. There were 2 more chapters, and they are short. In December of 2006, a company called Tree CNC, operating out of Brighton, Michigan, announced it had acquired an exclusive license to resume production of the J425 knee mill and to serve as the authorized source for original tree parts and service in the United States. Someone had looked at the demand still out there for that machine and decided it was worth restarting. It did not last. On the 15th of April 2009, Eagle Machine Tool Corporation announced that it had purchased the assets of Tree Machine Tool Company, formerly of Franklin, Wisconsin. 83 years after Charles Tree opened a die shop, that was the end of the paperwork. Chado Filipovich outlived the company that brought him to America by a wide margin. After Tree closed its Racine operations, he finished his career at Twin Disc, the industrial clutch manufacturer a few miles from where he had started, and retired in 1999. In 2013, he and Rosalie built a home in Superior, Wisconsin, on the far northwestern corner of the state. He died there on the 29th of October, 2023. He was 89 years old. He had crossed a border illegally at 20, sat in an Austrian refugee camp, and spent 3 decades in a Wisconsin machine shop teaching other men how to cut metal. Here is what is still standing. The building at 1600 Junction Avenue in Racine did not come down. There is a machine shop in it today, a firm called Apex Machine Products, running screw machines and CNC-turned parts. The address that Charles Tree worked out of is still making chips. The machines are still standing too, which is the part that would have pleased him most. Thousands of tree mills are still cutting, because gray iron and hand-scraped boxways do not wear out on any human schedule. A well-kept 2 UVR trades on the used market for a few $1,000s, which is roughly the price of a decent used car and a fraction of what a new machine of half its rigidity would cost. The electronics are the part that dies. Dynapath controls from the early 80s are increasingly hard to keep running, and the later Tree machines that shipped with PC-based controls running Windows NT have a habit of eating their own hard drives and taking the software with them. So the retrofit community strips them. They pull the dead control, keep the iron, and drop in modern motion control. Centroid, Linux CNC, whatever fits the budget. One retrofitter working on a journeyman 425 got hold of the original factory control schematics from the Czech operation that still holds the drawings. Which means, right now, in garages and job shops around the country, there are men taking 80-year-old Wisconsin castings and wiring them to computers that did not exist when the machine was poured. The thing Charles Tree built was never really a company. Companies get sold. What he actually built was a body of decisions about how stiff a machine needs to be, cast in iron heavy enough that nobody has been able to throw it away. If you want more of these, the ones about the companies that made the things that made everything else, subscribe. There are more of them than you would think, and most of them have never been told.